Okay, so this video is about testing for ions, and it's specifically for OCR Chemistry A syllabus, and it's the first year of A-level chemistry. Which ions do you need to test for? So the first ion is the carbonate ion, and when you're testing for the carbonate ion, you need to add acid. You can add any acid, but you need to add acid. The observation is that you'll see bubbles of carbon dioxide gas. So you'll see bubbles of gas. And what is happening, the ionic equation, is that you've got acid and you've got carbonate, and you're making bubbles of carbon dioxide gas plus water. And that's the first test. The second test is for sulfate ions. Okay, so for sulfate ions, you need to add barium ions. And it can be barium chloride, barium nitrate, as long as you're adding barium ions. And the observation is that you'll get a white precipitate. In future, I'm going to write that as PPT, just to save a bit of time. You get a white precipitate of barium sulfate. So the ionic equation is you have your barium ions and you have your sulfate ions, and you make the white precipitate of barium sulfate. So you can see it's a precipitate, it's a solid state symbol. The next ion to test for is halide ions. And when we're saying halide ions, we mean chloride, bromide, or iodide ions. Okay, so you add silver ions. So silver nitrate is what we add normally, silver ions. And then your observation, if you have chloride, then you'll get a white precipitate. And that's a white precipitate of silver chloride, solid. If you have bromide ions, then you'll get a cream precipitate. And that's a cream precipitate of silver bromide. And if you have iodide ions, then you'll get a yellow precipitate, and that's a precipitate of silver iodide. And the ionic equation is the silver ions plus, let's take chloride as an example, and you get the precipitate of silver chloride. Okay, now that's not the tricky part. The actual tricky part to this, which can be a long answer experimental question, is what would you do if you had an unknown mixture? Yeah, so you don't know whether there are chloride ions in there, you don't know whether there are carbonate ions in there, you don't know whether there are sulfate ions in there, and there may be more than one. So the tricky part is the order of the tests. What's the order, and being able to explain that order as well. So we've got 3 tests. Which one should we do first? Now, if we do the test for halide, if we do that first, so let's say we add some silver ions to the unknown mixture. Remember, this is unknown. We don't actually know what's inside. Okay, so say if we add some silver ions first, and we're hoping for a silver chloride precipitate is what we're looking for, but also silver sulfate is also a precipitate, and silver carbonate is also a precipitate. So if we add silver ions and we're hoping to look for silver chloride, we might get very confused results, because we might actually see a precipitate of silver sulfate, or we might see a precipitate of silver carbonate. So we cannot add the silver ions first. Similarly, if we add barium ions, then and we're looking for barium sulfate is what we're actually looking for, to see if we get a precipitate of barium sulfate. Barium carbonate is also a precipitate, so that will confuse the results as well. So therefore the order of tests is very specific, and the experimental details that go with that as well. So the order of tests is the first thing you should do is you should test for carbonate first. And what you need to add, when I said you can add any acid, if you're testing for a mixture of ions, then you need to be very specific and add nitric acid. Okay, there's no point adding hydrochloric acid. What will happen if you add hydrochloric acid? If you add hydrochloric acid, that will release chloride ions and confuse results. So you don't want to do that. If you add sulfuric acid, then sulfuric acid will release sulfate ions and again confuse the results. So you don't want to do that. So your first thing you do is you add silver nitrate, and you add nitric acid, and you add enough nitric acid until, so not just add it, you add excess nitric acid until the bubbles stop, the fizzing stops. Yeah, you want to remove all the carbonate from the mixture. So remember, we've got an unknown mixture. We don't know what's inside, but if there is carbonate inside, we want to add acid, nitric acid specifically, until all the carbonate has gone. Now, if you add acid and there are no bubbles, then that means that there isn't any carbonate. Okay, so that's the first thing that you do. Right, the second thing you do is you test for sulfate. Okay, so the second thing you do is you test for sulfate. And again, you want to add not just any barium ions, but you want to add barium nitrate. Barium nitrate, that's aqueous. Because if you add barium chloride, then you will be releasing chloride ions into the solution, which you don't want to do. So add barium nitrate. So always remember it's nitrate. Nitrate is what we're adding. Okay, and again, you want to add excess barium nitrate because you want to make sure that if there is any sulfate in there, that all the sulfate, when you add barium ions, you want to make sure that all the sulfate has gone. Okay, so you add excess barium nitrate. Now the problem is now you've got a white precipitate. So what you have to do before you continue is you have to filter to remove the white precipitate, because that's going to cloud the results, the white precipitate, because that's going to cloud the results for the last test. So you need to filter to remove the white precipitate. Now the only thing you possibly can have in here now are halides. So your final test, which I'm just going to write up here, the final test is the halide test, and that is where you add the halide test, chloride or bromide or iodide, and that is where you add silver nitrate. So again, it's nitrate because it doesn't get confused, and then you will look to see your color of your precipitates. Yeah, right, the final thing, those are all the tests for anions for first year. The last test you could be asked for is the cation ammonium ions. So how do you test for ammonium ions? So what you need to do is, to your sample, you need to add some sodium hydroxide. You need to warm gently, and in your test tube, so say you've got a test tube, and you've got you think it's an ammonium compound in there. You then need to use a piece of damp red litmus paper, which you hold in the neck of the tube. Damp red litmus paper. Do not let the litmus paper touch the tube. You've just got to hold it in the neck of the tube. And as you warm it gently, then you are going to get ammonia gas being produced. And the red litmus paper will turn blue. And the reason why it turns blue is because you've got your ammonium ions, which are reacting with the hydroxide ions, and they're releasing ammonia gas plus water. You've got water. And you've got to make sure that the damp red litmus paper does not touch the sides of the tube, because then it'll turn blue because of the hydroxide. So therefore you just have it in the neck of the tube, and the ammonia gas will make it turn blue.